Universe should not exist. According to the laws of physics as we understand them, the Big Bang created equal amounts of matter and antimatter, and they should have annihilated each other completely, leaving nothing behind. Every star, every planet, every atom of your body is evidence that something went wrong with that prediction. And CERN is trying to find out what. Antimatter is not science fiction. It is real. It is produced in laboratories every day, and it behaves in ways that are simultaneously familiar and deeply strange. Every particle of normal matter has an antimatter counterpart with the same mass but opposite charge. The electron has the positron. The proton has the antiproton. When matter and antimatter meet, they annihilate, converting entirely into energy in the most efficient reaction known to physics. The problem is symmetry. The standard model of particle physics, the most successful theory in the history of science, tested to extraordinary precision, predicts that matter and antimatter should have been produced in equal quantities at the Big Bang. If that prediction is correct, the universe should be empty. But it is not empty. It is full of matter, which means somewhere in the laws of physics there is an asymmetry. Matter and antimatter do not behave in perfectly identical ways. Physicists call this CP violation, the breaking of charge parity symmetry. We have found some CP violation. Experiments have detected small differences in how certain particles and their antiparticles decay, but here is the problem. The CP violation we have found is nowhere near large enough to explain the matter-dominated universe we live in. The asymmetry we can measure accounts for a tiny fraction of the imbalance needed. There is missing physics somewhere, a deeper layer of CP violation we have not yet found. This is where CERN comes in. CERN's ALPHA experiment, anti-hydrogen laser physics apparatus, has achieved something genuinely extraordinary. It has created anti-hydrogen, a positron orbiting an antiproton, the antimatter mirror of a hydrogen atom. Making anti-hydrogen is only the first challenge. Keeping it alive long enough to study is the real achievement. Anti-hydrogen that touches any normal matter instantly annihilates. ALPHA uses precisely shaped magnetic fields to suspend anti-hydrogen atoms in a vacuum trap, keeping them away from the walls of the container. In 2023, CERN's ALPHA collaboration published results in Nature that represented a historic first. They measured the effect of gravity on anti-hydrogen directly. The question was whether antimatter falls down toward Earth's gravitational pull or whether it might fall up. Some theoretical ideas, though not mainstream, had suggested that antimatter might experience gravity differently than matter does. The alpha-Gay experiment released anti-hydrogen atoms from the magnetic trap and observed which direction they fell. The result, anti-hydrogen falls down, at a rate consistent with the gravitational acceleration of normal matter, within the measurement uncertainties of the experiment. Antimatter does not fall up. Gravity appears to treat matter and antimatter the same way, consistent with Einstein's equivalence principle. That result rules out the most dramatic antimatter gravity anomalies, but does not close the door on smaller deviations that future higher precision experiments could detect. But here is where scientists are stumped again. Despite this result, the core mystery is no closer to being solved. The gravitational behavior of anti-hydrogen being normal is actually the expected result. What would have been extraordinary, and would have pointed toward new physics, is if the result had been different. So CERN confirmed what theory predicted, which means the explanation for matter's dominance is still missing. The ALPHA collaboration and other CERN experiments are now pushing further. Precision spectroscopy of anti-hydrogen is comparing the light emitted by anti-hydrogen to regular hydrogen with increasing accuracy. Any difference in the energy levels, any shift in the spectrum, would be evidence of CP violation at a fundamental level. So far, the measurements are consistent. Anti-hydrogen appears to produce the same spectral lines as hydrogen within current measurement precision. But current precision is not the final precision possible. Better measurements are coming. AEGs, G-bar, and BASE are additional CERN experiments, each attacking the antimatter mystery from different angles, measuring antiproton magnetic moments, testing gravitational interactions with different methods, and hunting for any deviation from perfect symmetry. And the stakes are existential. This is not abstract physics curiosity. The reason you exist, the reason anything exists, is that somewhere in the laws of nature, a rule was broken at the moment of creation. Finding that broken rule would be one of the most profound discoveries in the history of human knowledge. Follow for more frontier science, explained without the jargon. And tell me, if antimatter and matter are nearly identical, and yet the universe is made of one and not the other, does that feel like a solved problem to you, or the biggest open question in all of science?